This video is for Algebra 2. We're still talking about rationals. Remember that a rational function has a variable in the denominator, and that the first thing you want to do is simplify. And you really want to simplify both the top and the bottom of your fractions. So I'm giving you an orange paper. It's going to go in your notebook under thinking maps, and it's just kind of a reminder. Okay, you can look at it if you're not sure what to do first. And the first thing you want to do is factor, if that's possible, anywhere. Then you want to cancel, if possible. And then you want to remove discontinuity. Okay, this is otherwise known as a hole, which is what we're studying today. After you deal with holes, then you look for a vertical asymptote. Then you look for a horizontal asymptote. Then you're going to look at your graph. Your domain and range can be figured from the graph, or use your asymptotes and your holes. The bottom of this page is a reminder that the horizontal asymptote, you look at the degrees. If they're the same, you'll make a fraction with your leading coefficients. If the denominator is bigger, it's y equals 0. And if the numerator is bigger, there is not one. Okay, several little tricks for remembering things on this handout. If it helps you, great, use it. If not, memorize the rules. Okay? So, looking at your notes handout for holes in rational functions. A hole is present at x equal a when a is a 0 of both the numerator and the denominator. What this is saying is that you have a hole in your graph for anything that canceled in the top and the bottom from the beginning. In other words, your line's going along, there's just an open spot called a hole, and then the line continues. So to find a hole, the first thing you want to do is factor the numerator and the denominator. Once you have done that, anything that is in both the numerator and denominator, in other words, that would cancel, will be a hole. To find the hole, you put what you canceled equal to 0 and you solve it. This is the x coordinate of your hole. Plug this in to get the y coordinate, because your hole is actually a point. You know, our restrictions where x is not equal to a number. This is going to be a hole, and it's actually a point. Holes affect the domain the same way that the vertical asymptotes did. If there is a hole at x equal 3, then the domain is x is not equal to 3. So basically, a hole is a restriction, but it's listed as a point instead of x is not equal to a number. So find and classify any points of discontinuity, otherwise known as holes, for x squared plus x minus 6 all over 3x squared minus 12. First thing is factor. So on the top, we found the factors of 6, 1 and 6, 2 and 3. Signs are different. The largest is positive. It has to equal 1. So the top became x minus 2 and x plus 3. On the bottom, they both divide by 3. Pull that out, and it leaves you x squared minus 4. Difference of squares, so it becomes 3 times x minus 2 and x plus 2, which is what they have written on the bottom. Then you got to go find anything that's in both the top and the bottom. We have an x minus 2 in the top and in the bottom. They're going to cancel, which means you have a hole. So you take what's canceling, x minus 2, you set it equal to 0, you solve, and you get x equal 2. This means there is a hole at x equal 2. Then you go back and look just at your denominator, and we have the x plus 2. It's going to cause a vertical asymptote. So you set that equal to 0, and we have x equal negative 2. So you have a hole at x equal 2 and a vertical asymptote at x equal negative 2. So looking at number 1, the first thing you're going to do is factor the bottom, and this is a difference of squares, so it becomes x minus 3 and x plus 3. Start by looking for holes. Is there anything in the top and the bottom that's going to cancel? No. So then you find vertical asymptotes. So your vertical asymptote is going to be at x is equal to 3 and at x is equal to negative 3. I took each part of the denominator, okay, and set it equal to 0 and solved. Your horizontal asymptote, you got to look at your degree, okay? If the degree in the denominator is bigger, because of the top we have a 1, the bottom we have a 2, so the denominator was bigger, remember from your little orange paper, If the denominator is bigger, y is equal to 0. So we have a horizontal asymptote at y is equal to 0. As far as wholes, there are none. So we need to cancel if we can. Is there anything that will cancel? No. So wholes, is there anything in the top and the bottom? No. So you would say none. Vertical asymptote. You got to take x to the third, set it equal to 0, and solve. In other words, x is equal to 0. Horizontal asymptote. You compare your degrees. The degree is larger in the bottom, and so that means it's at y is equal to 0. So you want to factor if you can. So this becomes x minus 1 and x plus 1. This becomes x minus and x plus, factors of 3 that give you 2. It's going to be 3 and 1. Okay, you have an x plus 1 that's going to cancel. That means that you have a whole at x is equal to negative 1. Okay, the whole came because this is going to cancel. And so I took that over there and said x plus 1 is equal to 0. Move your 1. X equals negative 1. That's my whole. Vertical asymptote. You take what's left. If we've already used it for a whole, don't use it again for a vertical asymptote. And you're going to have a vertical asymptote at x equal 3 because we took the x minus 3 that was in the bottom and set it equal to 0 and moved your 3. Then you got to do your horizontal asymptote. Compare your degrees. They're the same. It's x squared in the top, x squared in the bottom. So it's at y equal 1 because we have leading coefficients of 1. And that's all for number 3. Number 4, you need to start by reducing. So x minus 1 and x plus 1. On the bottom, it is x plus and x plus, factors of 2 that give you 3. So you're going to have 2 and 1. So as far as a whole, you have an x plus 1 that's going to cancel. So x equals negative 1. I said x plus 1 equals 0. Moved my 1. Vertical asymptote, we've already used the x plus 1, but the x plus 2 will cause 1. So it's at x equal negative 2. Horizontal asymptote, I don't mind you abbreviating. Go back to your original problem. The degrees are the same. So it's going to be y equal, make a fraction with your leading coefficients, 1 over 1. So y is equal to 1. So moving down here, determine the whole. That's all we care about on this. What is going to cancel? It would be your x minus 2. So you have a whole at x equal 2. On this one, you're going to need to factor an x out, and it leaves you x minus 1. So your x is what's going to cancel, so x is equal to 0. On this one, you're going to have to break it down. It's going to be x plus and x minus, factors of 28 that give you 3. It's going to be 7 and 4. You got to pull an x out, and it leaves you x squared minus 11x plus 28. So don't lose your x. It's going to be x minus and x minus, factors of 28 that give you 11 are 4 and 7. So remember, we only care about wholes, which means it has to be something that's going to cancel. X plus 7, x minus 7 will not cancel. Your x minus 4s would cancel, and so x equal 4 is your whole. Pull an x out of the top, and it leaves you x plus 3. Your x's would cancel, so x equals 0 as a whole. Determine any horizontal, vertical asymptotes or wholes. Don't worry about that minus 1 over there because there's nothing under it. Okay, nothing's going to cancel, so no whole. Vertical asymptote of x is equal to 1. Horizontal asymptote, you have a degree of 1 in the bottom, a degree of 0 in the top. So that should be y is equal to 0 if the denominator is larger. Number 2, pull an x out, and it leaves you x minus 1. The x would cancel, so you have a whole at x equals 0. There's nothing to cause a vertical asymptote. Your horizontal asymptote, the numerator is larger, so there is none. It doesn't matter if you write it. If you want to make sure that there is no doubt, you would tell me none for both of those. Number 3, we have x plus 3 over x minus 3. There is no whole because nothing's going to cancel. You have a vertical asymptote at x is equal to 3. You have a horizontal asymptote. Your degree is the same, so you use your leading coefficient. Y is equal to 1 over 1, which is 1. You're going to have to factor, and so this is x plus and x minus. Factors of 3 that give you 2, so 3 and 1. So you're going to have a whole at x equal 1 because your x minus 1's cancel. No vertical asymptotes. Horizontal asymptote, your degree in the top or numerator is bigger, so there is none. Nothing's going to cancel, so there is no whole. You have a vertical asymptote at x is equal to negative 1. The degree of the bottom is going to be larger because when you do this, you're going to have an x squared. And so if the denominator is bigger, you have a horizontal asymptote at y is equal to 0. This is going to become x plus and x minus 3 and 2. Nothing will cancel. There is no whole. You have a vertical asymptote at x is equal to 0. And horizontal asymptote, you look at your degree, the numerator is bigger, there's not one. So all you have is your vertical asymptote. So what you're going to want to do as you work through these problems is remember to look for a simplify, look for a whole, look for a vertical asymptote, then look for a horizontal asymptote. Looking at number 7, this would be x plus 1 and x plus 1. Nothing cancels, so there are no wholes. Vertical asymptote is going to be at x equals 0. I just used the bottom. Horizontal asymptote, compare your degrees. 2 is bigger than 1. If the numerator is bigger, there is none. So all you have is the vertical asymptote. Number 8, I believe that's x to the third, so we'll pull out an x, and it leaves you x squared minus 1, which becomes x, x minus 1, and x plus 1. Don't forget to look for difference of squares. So your x minus 1's will cancel, so you have a whole at x equal 1. There's nothing else to cause a vertical asymptote. Looking at your horizontal, go back to your original problem. 3 is bigger than 1, so the numerator is bigger, there is none. Looking here, we're going to have, you could factor it. On this one, you can tell that the only thing that would cancel would be x, so you really don't need to spend the time factoring it. So there is no whole. You have a vertical asymptote at x is equal to 0. Look at your degrees. 2 is bigger than 1. There is no horizontal asymptote. Number 10, there is no whole because nothing will cancel with x minus 3. You have a vertical asymptote at x is equal to 3. Looking at your degrees, you have a 0 on the top and a 1 on the bottom because there's no x on the top. If the denominator is bigger, your horizontal asymptote is at y equals 0. The 2x, that x is not going to cancel with anything in the top, so you don't have to spend your time factoring. There is no whole. Vertical asymptote, you would say 2x is equal to 0 divided by 2. X is equal to 0. Horizontal asymptote, you compare your degrees. 2 is bigger than 1. If the numerator is bigger, there is none. Number 12, the x won't cancel with what's up top, so you don't have to factor it unless you just want to. You're going to have a vertical asymptote at x is equal to 0. Your degree in the numerator is bigger than in the denominator, so there is no horizontal asymptote. This one you need to see what you can do. Pull out an x, leaves you x squared minus 16. So that's difference of squares, and it becomes x, x minus 4, and x plus 4. Bottom one here, you could pull out a negative 4 because we don't really like that negative x squared. So it's going to change every sign and divided by 4. And it becomes x squared minus x minus 6. So keep your negative 4, and it becomes x minus. You will have a vertical asymptote at x equal 3 and at x equal negative 2.